Alright, Math 1, let's look at this homework 8.1. So the first thing to do is to find the distance between 2 points. So, AE. A is right there, E is there, so we can basically count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that would have a distance of 12. Okay, CF, same idea. 1, 2, 3, 4, 5, 6. However, may have just spotted a problem, huh? I didn't pay attention to the scale. Notice that if this is 2, that would be 1, a negative 1, so it would be counted by 0.5. So it would be 1, 2, 3, 4, 5, 6 for AE. So CF, 1, 2, 3, 4 and a half, or 4.5. For GB, okay, now we could also look and say, well, that's 4, and that distance right there is going to be negative 3.5. But if we think about distance as the absolute value, so of just positive numbers, 3.5 plus 4 would give us 7.5. Okay, we could count that to double check. 1, 2, 3, 4, 5, 6, 7 and a half. Okay, CA, 1, 2. BF, 1, 2, 3, 4, 5, 6. And finally EG, 1 and 2. Okay. Alright, number 7. Describe a way to find the distance between 2 points on a number line without counting the spaces. Well, we kind of did that, right? You could just add the distances from 0. Or just add, the absolute values of the points. Alright, now number 8 wants us to, using this triangle, find all these lengths. Okay, well, AB should be a pretty simple one, right? Because we can count A down to B, and it would be 4 units. For B, BC, it's horizontal, so we can count those units. We'd have 5, wouldn't we? Okay, whereas this one would be 4. Now, for AC, we can't just count, but instead we can use the Pythagorean Theorem. Remember that these two legs, since it's a right triangle, are A and B. The hypotenuse here would be C, the length we want, so I'd go 4 squared plus 5 squared would equal AC squared. 4 squared is 16, 5 squared is 25. Add them together, we get 41. So, to get rid of that square, we take the square root. So we could say the square root of 41, or in our calculators that would be about 6.4. And now the decimal keeps going at 6.403124237432849. At least that's as far as the calculator showed me. But we probably want to round to the nearest tenth on that one. Alright. Okay, number 9. Why is it easier to find the distance between point A and B and C than it is A and C? Well, because they match our grid, right? So we can just count. Whereas the AC, we can't. Okay. So how did we find the distance between point A and C? Well, we used the Pythagorean Theorem. Okay, which, right, we doubled, or squared, not doubled, squared both of those, added them together, then we take the square root of that, and that gives us our result. Alright, okay, so slope triangles and the distance formula. So triangle ABC is a slope triangle for the line segment AB, where BC is the rise and AC is the run. Okay, so we've got our slope here. We've just created this triangle with the rise over run. Notice that the length of the segment BC has a corresponding length on the y-axis, and the length of AC has a corresponding length on the x. So they're saying, hey, that length and that length match up. The slope formula is written as the slope, m, equals y2 minus y1 over x2 minus x1, where m is the slope. So what does the value of y2 minus y1 tell you? Okay, well, if we look at this again, y2 would be up here at 8. To get minus y1, it would be 4. Well, it tells us that change in vertical movement, right? So from, B to A or A to B. The x2 minus x1 right here, from 2 to 4, okay, distance of 2, kind of the same idea. Tells us the horizontal, though, change in movement for AC, okay? Which, we use that for slope, or we can use the Pythagorean Theorem, or we can, do that kind of stuff. So in the previous unit, you found the length of a slanted line segment by drawing the slope triangle and then using the Pythagorean Theorem on the two sides of the triangle. In this exercise, try to develop a more efficient method of calculating the length of a line segment by using the meaning of y2 minus y1 and x2 minus x1. So basically, you're making the triangle there, except instead of giving you the units, they want to use, you go 4 minus 2 and realize that that's 2, and then 6 minus 2 and realize that that's 4, and then go 4 squared plus 2 squared, so 16 plus 4 equals that, b squared, or c squared. So 20 equals c squared. So take the square root of 20, so ab would be the square root of 20, which if we use a calculator to help us find that out, take the square root of 20, and we get about 4.47. So we'll just say 4.5. We'll round up to the 10th. Okay, so 13, same idea. Okay, 16 minus 1, so that length, vertical, will be 15. 5 minus 2, right, so 16 minus 1 was that. 5 minus 2 is that. And that's 3, so we go 15 squared plus 3 squared equals what squared? So 15 squared is 225, 3 squared is 9. So 225 plus 9 gives us 234. Take the square root of that, and AB will equal about 15.297, so 15.3, we'll say. Alright, 14. Okay, so I can go negative 4.5 minus 1.5, okay, which would give us negative 6. So that was right here, so we went down 6, okay, and over we have 3.5 minus negative 3, so that would be like plus, so it ends up being 6.5. So we go negative 6 squared, which a negative number squared is always positive, so 36, plus 6.5 squared, oops, I don't know 6.5 squared off the top of my head, 42.25 equals that length squared. So add those two together, 36 plus 42.25, we get 78.25. Take the square root. We end up with 8.845, so basically 8.8. Okay, and finally the last one. Okay, find AB. So it'd be K minus Q. Okay. Well, yeah, we could do it that way. That would give us that distance, so k minus q. And this distance would be j minus p. Now, we'd normally take those numbers and square them, so we can take these, square them, and add them, and that's going to equal AB. Okay? Squared. Now, to get rid of AB by itself, we take the square root. So it's getting you to come up with this, which should look really familiar. Okay? And so that's the answer for 15. Alright, now rectangular coordinates. So, we're given some points here. So they want us to fill in the missing coordinates. So for G, for my X, I know that's negative 10. H, I know my X is negative 10. Up here at the top, I have B of 6, so I know K is 6. So I know H is negative 10, 6. Okay. A is 0, 0, so I know that that's 0, that's 0, that's 0. And down here is 0. I know this is negative 4, and that would be 10 and 10. So, negative 10, positive 10, add those together, our distance is 20. B to D, 6 and 4, negative 4, but distance of 4 would be 10. Okay, find D, on the next one. Okay, so same idea. That X would be 0, that X would be 0. This X would be 4, that X would be 4. 0 here, negative 3 here, negative 3 here, 0 here, 4 here, 4 here, negative 8, and negative 8. So DB, we have negative 8 here, positive 4 here, 8 and 4 give us 12. And CF, we have 4 here and negative 3 here, so 4 and 3 would give us 7. And there we go.